Aloha, you guys wanted it. You are going to get it. Here is the review video lesson for chapter 5. Some of you requested that maybe we can get these reviews as video lessons. So here you go. Here we go. 1A. Kind of fly through some of these guys, right? We've got a definite integral. I have 8 over x, and I have a rational. So remember, one important thing that we want to do when we're dealing with definite integrals is we rewrite these with negative and rational exponents. Well, this first one is 8 over x. So I don't really want to write over that one because that should be a light bulb, ding, 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 that would be a natural log, right? Plus 7x to the 1/3 plus x to the -4th dx. All right, so now we're going to take the antiderivative. Remember, it's like we have 3 mini problems there. That would be 8 natural log absolute value of x, because remember, you can't take the log of a negative, okay, plus 7x. I'm going to add 1 to that 1/3, and I'm going to get 4/3. But then I have to divide by 4/3. What the what? Right? We don't want to divide by a fraction, so we're going to multiply by the reciprocal in a moment. And then my last one would be plus 4. If I add 1 to that, I get a -3, but then I got to divide by a -3. Then we're going to do the FTOC, fundamental theorem of calculus, from 2 to 7. I'm going to keep on going here. We're going to get 8 natural log of the absolute value of x, plus what would that be? That would be 27 over 4, x to the 4/3, and then a minus 1/3 x to the -3, and we're going to evaluate that from 2 to 7. Remember, you plug in the 7 first, you plug in the 2 second, and then you should get an answer. All right, I'm not going to do the busy work of that. Remember, you can math 9 it to make sure you're doing the algebra part of that correctly. Okay, you guys, remember, don't try to tell me I'm going too fast. Just hit that pause button before I go to that erase. All right, you guys. All right, next one. This one definitely want to rewrite. We're doing B here. I'm going to come over here so I have enough room. My face kind of gets in the way. But remember, we got to rewrite this guy before we do it. All right, that's going to be 5x to the -3. Remember, big mistake on this guy is that is not a natural log. Remember, it has to be linear in the denominator. Plus 7x to the 1/2. And then plus, that's 1 over x. Now, that 1 over x, that's definitely linear in the denominator. So let's go ahead and find antiderivatives, right? I'm going to add 1 to that bad boy. It gives me a -2, but then I have to divide by -2. Plus 7x, if I add 1, it gives me a 3/2, and then I have to divide by 3/2, which I'm going to multiply by the reciprocal in a moment. And then the last one would be plus the natural log of the absolute value of x. And then I'm going to do the FTOC, right, from 4 to 9ers. All right, let's just rewrite this a little bit prettier. I get negative what? 5/2, x to the -2, plus 14 over 3x to the 3/2, plus the natural log of x. And I'm going to evaluate that from 9 to 4. Do that. Make sure you can do it by hand. It says 9 calculator. You can math 9 that bad boy to make sure you're 100% on top of it. Okay? All right, here we go. All right, these next guys, evaluate using geometry. Whoa, how the heck do I do that using geometry? Well, hopefully we recognize that that is that semicircle guy. All right, remember, if not, you got to solve for y. You got to go y equals, and you got to square both sides and all that stuff. But if I remember that's a semicircle, it's going to be centered at -2, 0, and it's going to have a radius of 5. Cinco, go on. 1, 2, 3, 4, 5. Booyah. 1, 2, 3, 4, 5. Booyah. 1, 2, 3, 4, 5. Booyah. And spling. Boom. There's my circle. We're going to go from -2 to 3. Oh, sweet. That is just a quarter of a circle with a radius of 5. Oh, nice and easy, Japonesey. I can do that, guy. That's 25 over 4 pi. Boom. Dunzo. See you. Hit pause if I'm going too fast. All right, here we go. Next one. We better know what this bad boy looks like, right? That is the V graph, right? And all I have to really know is it's translated. It's kind of, if you're really, really good, you understand that right? Going back to your pre-calc days, and I don't want to get too crazy on this, but I could factor out a 2 and I would get 4 plus x and that 2 right there, which means it's going to be shifted this way, right? It's going to be shifted this way 4 units, okay? And then it's going to have our slope here, all right? And it's going to be my v graph, and I better know the rest of it because I'm going to go from -6 to 1. And so you could, let's say if you weren't so sure about how that shift works, what you could do is you could make, actually, I was just going to get a little bit crazy on you, but really all I need to know just at a second thought is plug a -1 and a 1 in. If you plug a 1, if you plug a -6 in there, what do I get? 8 plus -12, that's 4. So it's going to be -6, 1, -4, -6, comma, +4. Booyah, that's a height of 4 right there, right? We know it's a V graph, and I know that's a height of 4, right? And I'm going to have to find the area of that. Oh, it's a triangle. And then if I plug a 1 in there, it's 1 comma 10. Boom, that's a height of 10. There's your triangle there. So that's just the area of 2 triangles. I'm looking at my answer here. You should get an answer of 29. You guys do that on your own, right? AP Calc, you don't need me to do that stuff for you. That's 1/2 base times height without a calculator. All right, let's keep it rolling, guys. Number 3, non-calculator. These, remember, are the derivative of an antiderivative. So remember, we would never want to do these the long way. The derivative of an antiderivative, right? We've got the shortcut for it. All we have to do is focus on the variable. There's a variable there, there's a constant there, so that's going to zero out if I were to do it the long way. So this answer, believe it or not, is just plug in an x wherever you see a t, and I'm done. So as long as I chain, and the derivative of x is Ichiban, so that dude is done. That is it for that one, right? Hit your pause button if you need to write that out. Okay, part B. Why don't I get this up a little bit here, you guys? What the what? We don't want to do that. Oh, snap. I see what happened there. Hang on, hang on. Hang on, hang on. Well, we got to erase that, dude. Let's go to the mouse. All right, here we go. Boom. Okay, some more of these derivative of antiderivatives, right? Derivative, right, of an antiderivative. And I've got an x, a variable on the top and the bottom. So remember, FTOC means you plug the top in first. So it's going to be the square root equals, right, 4. I'm going to plug in that secant, but that's more than an x there, right? That's more than an x, minus 9. That has to be all underneath the square root. And then I'm going to multiply it by the derivative of secant x. And the derivative of secant x is secant x tangent x, right? And that would be the chain of it. Right? And then it's minus because it's the FTOC, right? And it's minus. Now what am I going to plug in? A 5x to the 4th. And I'm going to put that in for the t, 5x to the 4th. You could simplify that if you want to, but then that changes to a 20x to the 3rd. So you could simplify that a little bit, but that is it, yo. All right, so if you're getting that, you're doing a great job. We got 2 more of these derivative of antiderivatives. If I were you guys, I would make sure you pause, or hopefully you have tried it on your own. For this one here, derivative of an antiderivative, you only have one variable, and the derivative of that x is just 1, so it will not change. Wow, Mr. T puts one that okay on this test. Right? All right. Last one, derivative of an antiderivative. Come on, be tougher. Oh, it kind of is. It kind of is. Derivative, right, of an antiderivative. So it's just going to be 9 over. I'm going to plug in that tangent. Ooh, that technically, little bit of a typo here. That should be a t right there. Okay, to technically do it correctly, that should be a t right there. So it's 9 over, plug in the tangent. So the tangent x squared minus 1, but the tangent x squared changes into secant squared. FTOC minus, now we're going to plug in that 3x to the 6. We're going to square that minus 1, but then that changes, and that changes to 18x to the 5th. Obviously, you could simplify, make that look a little prettier, but that's it. That would be done. All right, let's keep on going. This I just noticed this review is kind of a monstrosity, huh, you guys? How fun. I don't know about you, but the longer it is, the more fun it is. All right, here we go. Best thing about number 4 is we tie in the first half of calculus like with the second half of calculus. So I don't know about you, but I love these boys. All right, g of negative 1. What the heck is g of negative 1? Well, g of negative 1 would mean you just put a negative 1 in there for x. Now, those limits are backwards, and I've taught you that if we're looking at a picture and we are giving a picture and your limits are backwards, you better flip them. Be safe than sorry. And so this is just asking you negative, what is the area from negative 1 to 0, right? And that's just 1/2 base times height. If I do it correctly in my head, I get an answer of 1. So my answer for that guy, g of negative 1, is actually negative 1. Okay, I'm going to get my answers off here to the side, make sure I'm doing it all right. Sweet. 1 for 1. All right, here we go. I would have got that one wrong. Now I got to erase this just because I need the room. This marker writes a little bit big, but that's nice for you guys at home. G prime of negative 1. What the heck is G prime of negative 1? In order to do G prime of negative 1, I've got to find G prime of x. Well, G prime of x is equal to derivative of an antiderivative. Only one variable. Let's plug that in. Spling. So that means G prime of negative 1 is equal to f of negative 1. Well, f of negative 1, it says that this right here is the graph of f. F of negative 1, oh snap, it's right there. It is just zero. Let's check it. Sweet. 2 of 2. Let's go. Let's see if we can hit that tray piece. Let's see if we can go 3 of 3. Here we go. G double prime of net. What the heck? Double prime? Well, G prime of x, let's remember, was f of x. So G double, what the what? G double prime of x then is equal to the derivative. Okay, so if this is the graph of f, f prime is the slopes. Right? So G double prime of negative 1 is technically equal to f prime of negative 1. So what is the slope at negative 1? Oh, snap. That is a pointy place. So that means it is DNE because this slope is negative, this slope is positive. They don't match up. So it's DNE because it's a pointy place. Right? I could use limits if I really wanted to explain why, but the slopes do not match up. When the slopes don't match up, you don't have a derivative there, right? That's how we tie the first piece with the second piece. Okay, you guys? All right, let's keep going. On what intervals is g of x increasing? Whoa, let's think back to first semester. Okay, and I got to look up here at my, I'm missing a very important piece of information. And that is that g of x is equal to the integral from 0 to x of f of t dt. Okay, very important. Because when it's asking me when is g, right? Remember, this is a graph of x. That's graph of x. You're asking me about g. I don't have a graph of g, but I can use my calculus knowledge to answer these questions. So when would it be increasing? It would be increasing whenever the derivative was positive. Well, if I want to know when the derivative is positive, maybe I should do a little critical points, a little sign analysis, and it will answer all those questions for me. So g prime of x would tell me when g is increasing or decreasing because prime first derivative are slopes, right? And we could tell when a graph is increasing when the slopes are positive. Well, that's just f of x. Well, okay, so let's just do the sign analysis right here. F of x, what do we put on sign analysis? Well, when this is 0 or when this is 0 because they're equal to each other. And it's 0 at negative 1 and at 1. And then if you look, f is positive because it's above, positive because it's above, negative because it's below. So my answer for this should be that g of x is increasing from -2 to -1 union -1 all the way until 1. Why? Because g prime of x is greater than 0, or you could say because f of x is greater than 0, and those two are equal to each other. Good to go, right? And then I can even do, hey, when it's decreasing, right, you guys? But you got to make sure you explain your reasoning. And my explanation for that would be because g prime of x is greater than 0. And how did I know that g prime of x was greater than 0? Because f of x is equal to greater than 0, and they're equal to each other. Sweetie sweets. Ooh, I shouldn't erase that because the next question asks about concavity. Oh, and I really shouldn't be erasing any of this stuff, but you guys have all the good work. I just looked at, we're going to have to graph this bad boy. So let's go ahead and check it out. All right, concavity. Well, concavity would be the second derivative. And we already wrote that the second derivative is the first derivative. So once again, let's do sign analysis. Okay, so what goes on my sign analysis? Well, since this is the second derivative, which is the first derivative, and I have to use information about f because that's the information that they gave me. They gave me the graph. Well, on my sign analysis, I'm going to put when the second derivative, or in this case, the first derivative of f, is 0 or dne. So when are my slopes 0 or dne? Well, -1 is dne because of a pointy place. 0 is dne because of a pointy place, right? And my last one would be 1 because of a pointy place. And then remember, this prime guy means the slopes. The slopes are negative, then positive, then negative, then negative. So I actually have points of inflections at -1 and 0, right, you guys? 1 is not a point of inflection because the second derivative does not change signs. But this is asking me for concavity. And I would say it's concave up from -1 to 0 because g double prime of x is equal to f prime of x, which is greater than 0. That's probably even a better way to write that. Probably should have wrote it a little bit better in that first example. Okay, you guys, now how the heck am I going to draw a graph for this guy? Okay, we can use all the information we just did, and unfortunately, I kind of erased it, so I'm going to kind of look at my solutions over here, okay? All right. Well, for one, I could find a lot of values, right? For example, I could do g of -2. Well, g of -2 is just the integral from 0 to -2, right? So that would be the area, but I've got to flip that, right? Because the limits are backwards. So I can use some points here to really, really help myself out here. And -2 to 0 would be that, would be that. Oh, snap. What the heck? That would be a 1, that would be a 1, so it'd be -1 plus 1, which would be -2. So that means g of -2 is equal to -2. So here we go. Let's graph that guy. So it's there. Why do I pick that guy? Because it's an endpoint. All right. Maybe let's pick some other things to work with, right? We already did, I think earlier, they had us do g of -1. Gosh, I can't remember what the answer. What was it? Oh, g of -1. And we did this earlier, you guys. G of -1 was equal to -1. We did that earlier. Okay, so -1, common -1. So it's got to go through that guy right there too. All right. Oh, and I should really have all my other stuff, you guys. I apologize. I'm going to write this up here. G prime of x would be f of x, okay? And those would be, and then I got g double prime because this is concavity. And remember, when we graph this, we need all of this stuff. Should have been smarter and wrote out that I needed that so I can get a pretty nice graph. Well, this would be zeros at -1 and 1. And then we got pos, negative. So it's going to increase, then it's going to increase, and then finally it's going to decrease. Okay, let's go ahead and let me do the second derivative. Well, dne, dne, dne. Remember, those are slopes. Negative slope, positive slope, negative slope, negative slope. Remember, this tells me concavity. This tells me increasing, decreasing. All right, let's pick some more values to work with. Okay, what's g of 0? Well, I already have the answer over here to the side. Well, it's b 0 to 0. Well, 0 to 0 is obviously 0. So spling, it's going to go through that guy right there. G of -1, we did that. And then I could do g of 2. G of 2 would be from 0 to 2. Okay, and I think I've got, oh yeah, I've got all these answers over here to the side. So I'm just going to write them out really quickly. G of 1 would be 1. G of 2 would be 1/2. Okay, if you do all that area stuff. So we got 1, 1, and then we got 2, 1/2. All right, so what the heck is this going to look like? Okay, it's got to increase. It's got to increase until we get to 1. Okay, so we're going to increase all the way until we get to this 1 right here. We're going to increase. Okay, At -1, there is a point of inflection. Interesting. At -1, there's going to be a point of inflection. So here we go. What the heck would this graph look like? And it's got to be concave down. Okay, so it'd have to look like that, right? Miss Simmons does a great job in 2020 of kind of drawing these tangent lines. It's got to increase and be concave down, but then it's going to be concave up and still increase. So it's going to look like this. There's going to be like a little horizontal tangent there. Okay, that's what it's going to kind of be like, right? And that was a critical point for me up there. All right, and then it's going to increase, and then it's going to be concave down. So it's going to come back down here. It's going to be concave down. Okay, and then what's it going to do for the rest? It's going to decrease but be concave down. So then it's just going to continue to be there. So there's my graph. Sorry, it's not the cleanest thing in the world. I could zoom in there and get it a little bit better, but I don't want to take all the time in the world. Big time problem right here. Okay, very, very important problem. Okay, man, this is going to be a review, you guys. I better remember to give you guys enough time to really get this thing done. Okay, let's see, number 5. I'm going to hit pause, look at my answers. If it's the same type of problem, we might skip this one. All right, class, number 5 is really similar to what we just did. It's the same type of I guess, logistics or technique that you have to use. So what you're going to do is meet me at 7:30 in the morning if you need help with any more of this. Okay, it's the whole thing of the derivative of an antiderivative and how we use that to answer some of these calculus questions. Okay, here we go. We will do 6 together. Get out those calculators. All right, and here we go. It says we have the temperature in degrees Celsius of a water in a pond is a differentiable function W of t, which means it's continuous. The table below shows that the water temperature as recorded every 3 days for a 15-day period. All right, big time AP calculus question. What is W prime of 12? What the heck? That means derivative. But they only give me a table. They don't give me a function. Well, how do I use the table? Well, the derivative is a rate of change. Ooh, rate of change. So derivative rate of change, they don't give me a function to work with. There's 12 right there. So let's find the rate of change. Maybe let's book it. Let's sandwich it. Let's use 9 and 15. So this is just W of 15 minus W of 9 all over 15 minus 9, right? That's a rate of change. And rate of change, remember, means derivative. Looking at my answers here, just to save a little bit of time, the answer is -1/2. Now it says to indicate your units of measure. Well, if you look at this, right, if we do this, these are my W's right here, which on top is degrees Celsius over my days. Okay, so that's what happens. That is the rate of change. It is going down. The temperature is decreasing -0.5 Celsius per day. Okay, and that's what the meaning of that is. And you want to make sure you understand what the meaning is for each one of these problems that you do. And when you're working with units, it really helps you to understand what those units mean and what the meaning of the problem is asking us. Okay? All right, can I go up a little bit? I think I can go up a little bit more. All right, boom. Let's get my mouse there. All right, B, approximate the average. Oh, that word average integral divided by the interval, right? You better be dancing it at home. So that's integral divided by the interval. So I got to do the integral of W of t, and they don't give me a W. So how, Mr. T, how am I supposed to do this if they don't give me an interval? What the heck? Well, they tell you to use a trapezoidal approximation of 3 days. Oh, sweet, 3 days. How convenient, right? And so what does it mean? Remember, integral is the area underneath the curve, but I got to do trapezoids. Well, how do I do trapezoids? Well, remember, I taught you kind of a shortcut. I won't use the shortcut in case it gets you guys. But remember, I'm going to find the area underneath the curve using trapezoids. For the first trapezoid, be 1/2 the height. The height is 3. Why? Because their sub-intervals are length of 3 days. And then it's just base 1 plus base 2, right? Which are the Celsius. That's it. And then I just got to do these for each one of these, right? 3 times 31 plus 28 plus 1/2. Right? It's getting tedious now. 28. Remember, you use every one of these bases 2 times except the first one you use once. Oh, snap, I forgot my tree. Some of you guys probably said it at home, right? And then what would it be? 24 plus 22. And then my last one would be plus 1/2. 3, that's my height. 22 plus 21, right? You used everything. You use this guy once, everybody else 2 times, right? You could factor out a 3/2 to make your life easier. We're going to divide that by 15. Don't worry, you were allowed to use a calculator, and if you do it all correctly, you get 25.1 degrees Celsius, right? That's what we would get. Because on the top, your unit on top, since you're finding that area, right, would be degrees Celsius per days. And then if you divide by your days, actually, that's my average temperature, right? 25.1 degrees Celsius. All right. Hopefully that's okay. That's a lot of busy work. On the AP exam, though, that's going to be worth some points, right? That is definitely going to be worth some points. Okay, part C. I think part C, they kind of switch it, and I don't think I'm going to need the rest of that problem for part C and D. We'll check it out, though. Part C, a student proposes the function is a model for the temperature of water in the pond at time t. All right, P of t is measured in degrees Celsius. They're asking me to find P. Oh, nice and easy Japanese. Just got to plug that bad boy in your calculator and use Math 8. You plug that into your calculator and you use Math 8, you get negative 0.549. And make sure, you guys, that you round or truncate to that third decimal spot because this is a final answer. And since this is a rate and the model, it says, is measured in time and P of t is in degrees Celsius, that this would be degrees Celsius per day. Okay, right? Because that's a rate. It's like a rate of change. Remember, when we did the rate of change earlier, it was our degrees Celsius over a day. So that means it's going to, excuse me, let me get some water. Or some good tea with honey. All right, explain the meaning of your answer in terms of water temperature. So you would say that on the 12th day, that pond, its temperature is decreasing by negative 0.459 degrees Celsius, okay, per day. And that is on that 12th day. All right, I don't know. Maybe it's getting colder outside. Who knows? All right, D. Use our function from part C to average value integral divided by the interval. And so it's that easy, you guys, right? You could have struggled on that first piece, but then if you just knew this integral over the interval, you're good to go because this is just the integral of P of t dt from 0 to 15 all over 15 minus 0. So you math 9 the numerator, and if you do this correctly, you get 25.757 degrees Celsius, right? Because when you find that area, you get degrees Celsius times your days, right? And then on the bottom, you get days, splings, they cancel out, and you get degrees Celsius. Okay, and that's because, when you go up to this one here, you had degrees Celsius as your like y-axis, time as your like x-axis. You multiply those two guys, right? You get an area, and then days over days cancel out. You end up with degrees Celsius. Okay, hopefully that was okay. It's a very important AP Calc question. A lot of the times when we get to the AP test at the end of the year, that's a standalone question. Right, so you want to make sure you're okay with it. Oh boy, the mosquito question. All right, I'm going to get my answers over here to the side. Hopefully you guys gave this one a try. If not, hit pause, give it a try right now. All right, the very important mosquito question. One of the most important problems here, okay, in chapter 5 is this guy here. All right, we have rate of change. Ooh, rate of change. That means this is already like a derivative, right? The rate of change of the number of mosquitoes on tropical island on time t days is this. So that is a rate, right? It even says mosquitoes per day. Let's circle this, dude, because it says there's 1,000 mosquitoes on tropical island to start at time t equals 0. It says show that the number of mosquitoes is increasing at time t equals 6. Well, this can really mess with our heads, okay? Because the number of mosquitoes, right? Boom, number of mosquitoes. Okay, if I want to know if the number of mosquitoes is increasing or decreasing, I have to take the derivative of the number of mosquitoes. Guess what? This is already the derivative for the number of mosquitoes. So I just have to do R of 6. Look at my handy dandy answer guide here. R of 6 is equal to 4.438. And remember, that is mosquitoes per day. All right, and we should say that is the number of mosquitoes per day at time t equals 6. Okay, so that shouldn't have been too bad. What some students sometimes do is what the next part is asking for. And part B says at time t equals 6 is the number of mosquitoes increasing at an increasing rate. Well, we already know it's increasing. Now I want to know if that is increasing, right? So I have to take the derivative of the derivative, right? So then this would be r prime of 6. And r prime of 6, right? It says a calculator question. I taught you guys you plug in anything that they give you right off the bat. And r prime of 6, that's equal to, and make sure you guys are doing these in your calculator, okay? Negative 1.913. All right. And then I just make sure it says give a reason for your answer. And I would say the number of mosquitoes is increasing at time t equals 6, right? We got this, but it's increasing at a decreasing rate. And how do I know that? Because r prime of 6 is less than 0. Sorry, guys, had a little interruption right there. They were putting some stuff in the rooms. All right, here we go. Part C. According to the model, how many mosquitoes will be on the island at time t equals 31? Round your answer to the nearest mosquito. Cut one of those dudes up. All right. Um, oh shoot, I need to know the total number of mosquitoes. And hopefully by now, you know, whenever we want to find the total amount of anything, we usually take the integral of a rate, right? Because we were given R of t, and R of t stands for mosquitoes per day. So if I just take the integral of that, boy, it's going to give me the total amount of mosquitoes. Now, the one thing you have to be very careful about is we start this problem with so many mosquitoes on the island. All right, so I'm going to create a function here, okay? That would be n of x, because I'm going to use the same variable that we use in our answer key that's on my website. All right, we start with 1,000 mosquitoes, and then I'm going to add to that 0 to x, right? R of t dt. There it is. That's going to be the number of mosquitoes on that island at whatever I want to know. And if I want to know how many mosquitoes are on there at, n of what the what? 31, that means it's going to be 1,000 plus the integral from 0 to 31. It's going to add up all those mosquitoes. Man, it better not be a lot. I know in Hawaii, usually we do get a lot. I got 964.35192. Now, how would the AP want that answer? Well, it said to round to the nearest whole number, so that'd be 964. So there's 964 mosquitoes at time t equals 31. Hopefully not too bad, right, you guys? Where it gets a little bit tougher is in the last piece where they ask me what is the maximum number of mosquitoes. And we all know max and min, oh snap, right? That's an extrema type problem. And whenever we have an extrema type problem, that means we got to do a derivative, critical points, and all that stuff, right? And we're even given some endpoints here. So that means I got to check endpoints, and then I got to show analysis. What the what? All right. Well, let's do it. We can get this, right? Well, first, what is our equation for the number of mosquitoes, right? It's this right here, right? We just created it to find out how many mosquitoes there were at time t equals 31. So what am I going to do now? Well, let's just go ahead and find the derivative, right? Because a derivative gives me maxes and mins. So let's go ahead and find n prime of x. Well, that's the derivative of 1,000 is 0, and the derivative of an antiderivative is just, what the heck? It's just r of x. Well, that's not too bad, is it, class? That just means I got to find critical points, and I want to find when r of x is 0 or dne. Now, what you want to do, and you've done this already, hopefully, but you want to graph r of x. Okay, if you graph that in your calculator, I kind of have a little thing here. Your graph should look like that. Okay, and you know you've got to go from 0 to 31, and it's going to be critical points here and here. And right there's kind of a sign analysis there: positive, negative, positive. So that means your original graph will increase, then decrease, then, oh snap, there's a max right there, right? And if you did this correctly, let's call that A, let's call that B. And then remember, when it says to show your analysis, we're really going to have these x critical points and then the number of mosquitoes. So remember, you always have to check endpoints 0 and 31, but then you have to make sure you put A and B in there. Well, what is A and B? Well, if you did it correctly, set that equal to 0. A should be equal to, I got it right here, 7.8539.816. Make sure you store that. You are never supposed to round until you have a final answer. And that's B is 23.5619445. All right, and then all you have to do is plug this. Well, that'd be 0 to 0, so that'd be 1,000, right? You already did 31. That was in part C up there. So then you just got to put an A in there, put A up there, put B up there, and the answers that I got was 1039 rounded to the nearest mosquito, and this was 842, which makes sense. That was the minimum. That was the maximum. So the answer is, let's read the question here. To the nearest whole number, what is the maximum number of mosquitoes? 1039. I don't want to be there at time A, which is 7.8539816. Da, 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 da. All right, big time important problem. We are going to do one more of these, and I might cut this video into 2 parts because boy, does this guy get long. This is just page 3. We still got 3 pages to go. Man, I'm glad I did this. I better give you guys enough time to get this review done, right? No calculator. Let's get this guy. Oh, come on, Mr. T. Please put a lot of these on that test, right? 3 to 3, that's going to be 0. 5 to 1. Well, remember, these are like proofs. I want to use these bad boys. The only way I can use those bad boys is to show I have exactly it. So for this, the equivalent from 5 to 1 would be negative 1 to 5. Now I can use substitution, which would be negative 13, which would be 13. Boom! I'm going to have to erase. Marker right's kind of bigger. Maybe it's you that write pretty big. All right, here we go. Next one, 1 to 5. Well, I've got f of x and g of x there, but you've got to use that property that the integral of a difference is the difference of each of the separate integrals, right? So we got to flip those up. That right there is 7. That right there is negative 13. Oh, snap, I got 20. Did I get it right? Man, I sure hope I did. Let me get over here and zoom up. Oh, yes, got it right. Well, I'm going to have to zoom. I'm going to have to erase here, and then I'm going to have to go a little bit higher because my face is in the way. All right, let's go a little bit higher. Hopefully, I can still see everything. I think I can. All right, here we go. 2 to 5. All right, remember, this was usually the toughest one. Oh, no, I do have to come down a little bit. A little bit. Come on, come on, come on, come on, mousy mouse. What if I go like, what the what? What if I go, what the what? Maybe I got to come over here. Just get on. All right, there we go. All right, let's go from 2 to 5. Well, remember, we kind of did this in class. All right, and we are given the integral from 1 to 5 of f of x, right? And that would be equal to the integral from 1 to 2. Now, why am I using all this? Well, because guess what? They gave me this stuff. All right, and let's see, is that a correct statement? 100, that's 100% correct, right? If I go from 1 to 5, that's equal from going from 1 to 2 and then adding on from 2 to 5, right? Same thing. And now what? Nice and easy, Japanesey. That dude's negative 13 equals, that dude is tree. This one I don't want to know, which is okay, because that's what I'm trying to find out. Subtract that tree on both sides, I get negative 16. Did I get it right? Sweet! Check a shack. Right? We got 2 more to go. Okay. Hopefully that's okay. I always think D is the toughest. So if you got that one on your own, you're just doing a beautiful job. All right. This one here, I'm gonna come up here. We just gotta split this up. And I'm gonna kill 2 birds with 1 stone. I'm gonna bring the 3 out, because you gotta bring the 3 out, right? And then you have x dx. Then I can use that property, which is right there. And then we're gonna subtract the integral. Remember, this is again the integral of a difference, is the difference of the integrals. So that'd just be 3 times negative 13, which is negative 30 times negative 39 minus another. I get negative 46. Right? Yes, got it right. Darn, I am on fire today. Fire. All right, here we go. Last one. Oh, last one. You just got to bring out that 1/4, right? So you got the 1/4. I thought it was going to be tougher, right? Just got to bring out, you can always bring out any constant, you guys. So it'll be 1/4 times 7. 4. Did I get it right? Sweet. Sweetie sweets. You know what? I think I might just try to power through at least one more page. Let's check it out. You guys can always pause this and come back. What I'm going to do is the last really, really important one. Then you're off on your own for the rest, all right? You got the solutions, you can work through it, but number 10 is a very, very important question. So let's do it together, all right? And it touches on that topic that we did earlier, okay? But it's so important, so I'm going to make sure I do it again with you guys. Okay, guys? All right, here we go. H of 0. What the heck is H of 0? H of 0 just means you put a 0 in for x, right? That's all it means. And you should already know that 0 to 0 is 0. Sweet! 1 of 1. H of 12. Is H of 12 positive or negative? Okay, 0 to 12. F of t dt. Let's check it out. This guy means area. Well, come on, Mr. T. That area above is definitely bigger, so that's going to be greater than 0. How could I explain it? Well, I would just say the area from 0 to 6 is much bigger and positive than the negative area from 6 to 12. That's it. All right. H prime of x. Here we go. Here's the important piece. Derivative of an antiderivative, right? So that's just equal to f of x. Okay, and then they're asking me to do h prime of 0. Well, h prime of 0 is just equal to f of 0. Well, what's f of 0? It is hachi, hachi hach, or 8, right? It's right up here, right? Because this is the graph of f. All right, now let's get to the nitty gritty. All right, is h of x increasing or decreasing? All right, and I'm going to kind of do all of this work here because my picture's up there, okay, you guys? So to know if h of x is increasing, remember, we have to take the derivative of h. Well, the derivative of h, remember, is just f of x, okay? And so if I was doing sine analysis, I would need critical points for the derivative. I would want to know when the derivative of h is 0 or dne. Well, since it's equivalent to the graph of x, I just need to know when the graph of x is 0 or dne, which happens at 6 and at 12. And then the graph is positive, negative. Guess what? That means it's increasing from 0 to 6. Why? Because the graph of f of x is above the x-axis. That's simple. It's decreasing from 6 to 12. Okay, I'm going to answer all these questions right here. H double prime of x, okay, which would be f prime of x. Well, H double prime of x, where are those critical points? Well, I would have a H double prime of x would be 0 or dne whenever f prime is 0 or dne, and that would be at any pointy places, vertical tangents, or horizontal tangents. And I only have one horizontal tangent, and if I'm looking correctly, it happens at niners. And then all of your slopes are negative, then they turn to positive, which means 9 is a point of inflection. Now, I'm not going to scroll up because I still might need this picture, but the next F asks when it's concave up. So it's obviously concave up from 9 to 12. Why? Because H double prime is greater than 0, F prime is greater than 0. Okay, it'd be concave down from 0 to 9. There would be a point of inflection at 9. All right, part G, the really, really important one. It says when is h of x at its maximum? Well, all right, I'm not going to scroll up here, but how do I find when h of x is at its maximum? Well, to find out when h of x is at its maximum, I'm going to find the derivative of h of x, which I did right here. That's why I'm not scrolling down. And I need to know the critical points. And the critical points are 6 and 12. And that means h of x will increase, then decrease. And so that means this guy here is going to be a maximum. But remember, if you look at G, it says to, what does it say there? Okay, it says to justify your answer. So for part G, I'm going to write it over here to the side. Okay, that means you have to make sure you test not only your critical points, which would be 6 and 12. Okay, 12 is an endpoint, so it's going to be 12 anyway, but you also got to check 0. And then we're going to put h of x right here. Well, we all knew that that was 0. Okay, and then, hey, it would be, you'd have to do areas here, but I don't think they ask you to even do it. No, they don't. So you could just, and we actually answered this question earlier. Okay, the integral from 0 to 12 of f of t dt would be smaller than the integral from 0 to 6. And we know that, remember, by the areas. This area, right? And then you're going to subtract. So this easily is the answer. I was able to justify it. Even in the notes right here, you don't have to write out the entire answer, okay? But I think the one thing looking at the solution that I almost missed is, did they give me an initial? Did we start somewhere? And we didn't. We did not start anywhere, so we are good to go. So I missed nothing. All right, I'm gonna scroll through the rest of this really, really quickly, and if there's anything huge, and everything that I skip is huge, but it just might be a little bit repetitive. If you don't think it's repetitive, or if you're messing up a little bit, yeah, like you guys should be okay with 11. You should be okay with 12. You should be okay with 13. This turns the problem we just did into an acceleration velocity question, which you better be able to do. And you can use these solution guides to help you to get that. If not, you can meet me in the morning. All right. And let me know when you need some extra help, because I will be happy to help you out. Dominate this chapter 5 test. Let's get it. Let's get it. Alohas.